Oopsie doopsie. All right, let's look at 21. The diagram shows the path of a model rocket launched from the ground. Okay, so we have a nice little rocket there. It reaches a maximum altitude of 384 feet when it is above a location 16 feet from the launch site. So from here to here, 16. That gives me 384. What quadratic function models the height of the rocket? Oh, this one's a nice one. A little bit of a different problem because it kind of gives us everything, right? And then it asks us to write the equation. So I'm a labeler. I'm going to label first. So for number 21, just by looking at that, I know the vertex, right? It tells me where the highest point is, and I can see the x and the y. So I'm going to label my vertex is at, and that would be at the point 16, 384. And so I was just kind of looking at the thing. And then it says, what quadratic function? Well, I'm excited because I have the vertex, so I could just do it in vertex form, but I need A is the issue. So what I want to do while I'm looking at that setup is I also want to label a point. And the only other point that I really know is that point at 32 feet where it hits the ground. So that would be the point 32, 0. Oh my God, man, technology. Oh Lordy, there we go. Okay, thank you. Yep, always just yell at me. I'm always at the board. So I'll leave that up for a second. So once again, I'm just looking at my little sketchy. I'm saying, I can just see the vertex right there. That's a point 16, 384. But in order for me to write something in vertex form, I also need A. So to find that, I'm going to find another point somewhere on there. The only point that's really labeled is where it hits the ground at 32 feet. So I labeled that point as 32.0. And then we've done this step a few times now, where we think about vertex form. We label this as HK and this as XY. And we're going to plug in what we know so we can solve for A. So that will give us 0 equals A, X minus H squared plus K. Okay, so I can plug into a formula, no problemo. What does that give me? So 32 minus 16 is 16. Squared is 256A. And I just used my calculator to solve that. I subtracted 384 and divided by 256 to get an A of negative 1.5. Make sure you always go back and actually write the equation. So don't just say like, ooh, A, exciting. So your equation would be y equals negative 1.5 x minus 16 squared plus 384. There you go. So basically, you're just taking what we've been doing. It's just like they gave us a diagram instead of just giving us the information. So not too much different in terms of work. So that's that. Okay, I'm just leaving that up for a minute since I did a job of putting my board up before. So let's look at 22. We're just kind of cruising through these, doing as many as we can, because the more we do, the less you guys have to do. All right, so 22. To make an enclosure for chickens, okay, there you go. A rectangular area will be fenced next to a house. Okay, that makes sense. That's the house, and then you do like the little thing off the house. Only 3 sides will need to be fenced, and there is 120 feet of fencing material. What quadratic function represents the area of the rectangular enclosure where x is the distance from the house? Okay, so this is x. That's good to know. And what dimensions will maximize? So that's where once we actually have the equation, we're going to find the vertex of it. Let me. Oh, there we go. Because I actually remember to go back to it. So I'm just going to do that quick little drawing just so we understand where this equation is coming from. So our drawing was we have a wall. Okay, that's a wall. I'm aggressively coloring it. And then we have fence, fence, fence. And it told us this was X. Hey guys, if this is X, what's this? X, okay, right, it's a rectangle. So that one's going to be on the other side. Now we need an expression to represent this. I know I have 120 feet of fencing. Can anyone think of how I would write this? If this is X and this is X, and I have 120 total, this is just going to be 120 minus 2X, right? We don't know what X is, that's the issue. If I just knew it was 7, I could just do 7 and 7 and subtract that from 120. But since we're saying X and X, and we have 120 total, this side we're just going to say is our total, but I have to subtract those 2 X's off, whatever it is. So when we are doing area of something, it's length times width. So we're going to multiply those 2 sides together. I'm going to do, you don't technically need to multiply everything, right? So width is just that times that. So we're going to do X times 120 minus 2X. And we're just going to say that equals Y. Okay, that's exciting. So I'm going to just distribute that out. That gives me 120X minus 2X squared. I have to write it in standard form or I'm going to go crazy here. Okay. 120X. So that was A. What quadratic function represents the area of the rectangular enclosure where X is in the house? Okay, there you go. Y equals the length times the width, multiply them together. There we go. Okay, that wasn't that bad for A. And then for B, we want to maximize it, aka we just, anytime you see maximize or minimize, it's just a vertex problem. So I'm going to do negative B, which is negative 120, over 2 times A. That just gives me negative 120 over negative 4, which would be 30. So remember, what does that even mean? X, what is X? X is the distance from the house, okay? So we can go 30 feet from the house. And then we can plug that 30 back in to find that distance kind of off to the side there. So we could do 120 minus 2 times 30. And that's going to give us 60, right? 60 feet, I'll just write across. So a 30 foot by 60 foot fence would be the best. It doesn't technically ask, but the area would be 1,800 square feet. So something you would just take them and multiply them together. That makes sense. If this is 60 and then 30 and 30, that gives me 120 feet of fencing, and I am in good shape. Someone like that with a setup, either I'd give you one exactly like it, or I'd kind of give you a hint as to the setup of it, or even give you the equation. So don't worry too much about getting the original equation. Most of them were given to you. All right, we're chugging along here. Let's go to 23. Okay. The path of a football travels when Bryce, the path a football travels when Bryce throws it can be bounded by the function. We have a nice little function here in vertex form, delightful, where h is the height of the football and t is the time in the air. What is the maximum height of the football? Oh, I'm loving this one because it asks for maximum height and I know the vertex. So that's delightful. I don't even need to find that. So I'm going to go back. So for 23, I always like ones where there's not a lot of work. When I'm looking at that, I'm just reminding myself, just by looking at the equation, the vertex, just by looking at it, is at 2.5, comma 12.25. And this is where the labeling is important once again, because it says, h is height and t is time. Okay, that's exciting. But when we think about the equation, This is, I think I labeled that totally wrong. Yeah, this is time, right? Because that's with T. And that would be height. Just think about your XY. We're just labeling it TH. So I'm a labeler to start. So for the first one, it says, where am I? What is the maximum height? Oh, no wonder. I like totally labeled this wrong. The maximum height is 12.25 feet. Didn't have to do any work. It was just there. Maximum is the vertex. We knew the vertex. It was in vertex form. Sorry, I'm just following my reasoning here. How long is it in the air? Okay, that's exciting because it's not using the vertex. We don't really care about the vertex at this point. How long something is in the air, right? Bryce throws it. It hits a maximum right here, but it's in the air until over here, which is what I care about. So this one we would set up a quadratic equation. We would set it equal to 0 because we want to know when the height is 0, aka when it's hitting the ground, and we'll go from there. So remember, we're used to like, oh, you just plug it in, you use quadratic formula, but it's not the same when you have something in vertex form. So just remind yourself, what is the most efficient way to solve? I would highly suggest using square roots, where I would subtract 12.25. Okay, so negative 12.25. Sorry, it takes forever to write this bad boy. I divide by -1. Remember, do not distribute that in because that's something squared. That's not going to work. So I get 12.25 equals t minus 2.5 squared. And now I can take the square root of each side. So always go into it with a plan. Obviously, when we see standard form, a lot of times we're just like quadratic formula because we know it'll work type deal. But with vertex form, it is a little bit different. So just be careful there. The square root of 12.25, is it 3? 3.5. Just remember when you take square roots, that plus or minus. So it's plus or minus 3.5 equals t minus 2.5. And then I can add. So we can write this as 2.5 plus or minus 3.5, but we can actually combine, right, to find our two answers. And my two answers come out to be 6 and -1. You can't have negative time. So my final answer would be, it would take 6 seconds for it to hit the ground. And then the last one, it says, where is the height of the ball at 0 seconds? So when I'm thinking about good old Brycey over here, he's not throwing from the ground. That would be kind of awkward way to throw a football. He's obviously throwing it from wherever he throws it from there. So the height of the ball at 0 seconds, if I look at the vertex of form, it would be the y-intercept. And to find the y-intercept, this is a terrible picture. Hey guys, how do I find the y-intercept? Can anyone reminds me? Or I'll call this, how do I find the h-intercept? Plug in a
0 for t.
Plug in a 0 for t. So that makes sense. Where is it at 0? I don't know. I don't even know what I wrote for an answer. It is this one's up to. So if I throw in a 0 for t, which makes sense because it says where is it at 0 seconds, what'll I get? 0 minus 2.5 squared plus 12.25. It was 6. So that just means, what does that actually mean? It means when it left his hands there, when he started to throw it, it was 6 feet above the ground. Delightful. So we got through a few here. So now we're kind of skipping around because once again, not all of our word problems were in the same section. So can we skip, I think the next word problem is 39. So let's skip away to 39. Let me get that up so we can kind of look at it. Okay, so 39, we have a small independent motion picture company determines the profit P for producing N DVD copies. So remember, P is profit, N is how many DVDs we're talking about. So it gives us a nice little equation there. P is the profit in thousands of dollars, and N is in thousands of units. So obviously, hopefully they're selling more than a few. How many DVDs should the company produce to maximize the profit? Hey guys, what are we finding? Someone help me. We're finding the vertex. Hey, everyone, right now, can you just find the vertex of that? And that's your vertex is going to be your answer for A and B. So A is going to be the H of your vertex, and B is going to be the K of your vertex. So it's just asking you two questions about the same thing. So you guys can do these. It's just once again the wording sometimes a little bit annoying. And 39. My board. So once again, negative b over 2a. So your equation's nice and standard form, so you're good. I got 85. Did you guys get that?
Yeah.
Now just remember, I'm going to be like technical. It says N, which we just found, is in thousands of units. So I'm going to write 85,000 DVDs. Once again, if you're a production company and you're only making 85 DVDs, you're probably not doing too good. So 85,000. But you can just plug 85 in, right? So when I'm plugging it into the other one, or back into the original equation to find P, I got 128.5. So you guys get that for B? Oh my God, anyone? What did you guys get for B?
142.
Yeah, did I do it? I like blatantly put it on. I did this. This is from last year. So you took 85 and threw it in? Uh, 85 squared plus 3.4 to 85 minus 16. Yep, I don't know where I got that from. Where was I doing? Oh, wait, no, there should be a negative there. No, I got 128.5.
I did it wrong.
Make sure that, you know what, I did the same thing. Make sure the first 0.02 is negative.
Yeah.
Because I just did the same thing. I was like, I was wrong. You guys make me second. It was 128.5. Remember what that means? I just put like that and I put 1,000 because I was kind of lazy. So it'd be 128,500. But if you write it like that, that's fine. And that would be their maximum profit. So that's how much they can make to maximize their profits. All right, so let's just look at kind of 40 because these next few ones are quick. It's just a lot of finding vertices. Will be more. So number 40, a local nursery sells a large number of ornamental trees every year. Good for them. The owners have determined that the cost per tree, C, for buying and caring for each tree before it's sold is, and they have a nice little equation. In this function, C is the cost per tree in dollars and N is the number of trees. So A says, how many trees will minimize the cost per tree? So anytime minimize, maximize, we talking about the vertex. So I'm going to go back to my equation. I'm gonna do negative b over 2a. So we're seeing that that's popping up in a lot of our word problems, so something to look at in the future. So I get negative and then negative 0.3 over 2 times 0.001. Okay, so it's kind of a fancy thing. I just threw that in a calculator, and it should come out to 150. Remember, that's representing the x of your vertex. When we think about our equation, it represents n, and that's number of trees. So that's 150 trees. Okay. So that minimizes the cost. What will the minimum cost per tree be? Okay, well, at that little spot, we can just plug that in, if that's the minimum trees, into our nice little original equation. Oops. Okay, so that was a big pain, but you just throw it in a calculator, so we don't care too much. And I got 27.5, 2750 per tree. Will be the minimum cost. Oh, that's it. Oh, that one's easy. I thought the next one was the same problem. All right, so we saw in 39 and we saw in 40, the vertex is going to be a lot of your answer. So just keep that in mind as you work it. 41's the same, so let's just do 41 quick while we're here, and then we'll try to find just one or two more, and then we can kind of give you a few minutes to try the last. But that will be a good chunk of our word problems here. So find the max height, blah, 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 blah. When it says maximum, I know it's going to be the vertex. We have a nice little equation. Does that say plus VT? Oh, why is it? That's kind of annoying. So it gives you this equation, and then it tells you right before the velocity is 40. So I'm going to replace that with 40. I know, I was like, what is happening? I don't know. That was kind of weird wording. So I just threw the velocity in for v, and then I have a nice equation. And then once again, it said maximize negative b over 2a. We're getting used to that step for sure. Well, that would be negative 40 over negative 10, so that would come out to 4. And that would represent time, so that would be 4 seconds. So that represents time. Make sure you know what it represents. Think about what the x is. The x is replaced with t, so that's time. And then we just throw that back in the equation to find h. Gosh. H equals negative 5 times 4 squared plus 40 times 4. And the maximum height would be 80 feet. All right, so a lot of those were very similar to each other. Maximize, minimize, we know what we're looking for. And that is just the vertex, so there you go. I don't see anything on the next page. Sorry, I'm just flipping through looking for stuff. We have 58, 59, 60, and I think that's it for word problems. Okay. So I'm going to look at 58. I'll just look at it here too. Read. Okay. So 58, the length of a car's skid mark, what do you know, is a function of the car's speed in miles per hour. So we get a little equation, but we'll go with it. L is the length of the skid mark, and S is the speed in miles per hour. If the length of the skid mark is 220, find the speed. Okay, so that's not asking for maximum or minimum or anything like that. Excuse me. On the wrong page. Boop. I'm just going to kind of set up these last few ones with you, and I'll see. Maybe on your little way here. Wait, which one am I doing?
58.
58. I'm on the wrong one, no wonder. So that one, once again, not asking maximum, minimum. It just asks for the length, which is L, at 220 feet. So I would just take my equation and replace L with 220. I'm gonna be honest, that's like an annoying equation. So you would set it equal to 0, and then I would just use quadratic formula. And then remember, for word problems, we are gonna just estimate to a decimal. So we don't want, if it's a radical, that's just fine and dandy, but it's not very relatable. I'm just seeing if there's anything funky about the other ones. 59, how high after 1 second you throw it in, maximum, when does it hit the ground? You guys can do that. And 60, maximum. Okay, actually there's one more thing I wanted to go over. So I just quickly want to go over one thing, and I'll kind of give you guys the last few minutes to, there's only a quick few other problems, so you should be in pretty good shape. But let me just look at the thing. So for the people in class, just make sure you're looking at this one. Can you guys look at 60? So I just want to make sure I point this out to you before I give you a few more minutes to finish up. So we have the profits of Mr. Unlucky's. Oh, with a name like Mr. Unlucky, things aren't going to go good. Company can be represented by this equation. Y is the profit in hundreds of thousands of dollars. Well, I guess I'm going to do that. And X is the number of years of operation. So the more he operates, the more money he's making, hopefully. He realizes the company is on the downturn. Oh no, and he wishes to sell before he ends up in debt. So when will Mr. Unlucky's business show maximum profit? Okay, we're good with that one. So maximum profit, you just find the vertex. Okay, you guys can do that. And then what is the maximum profit? You just plug in your answer from A to find the maximum profit for B, because those are just the two parts of the vertex. I just want to point out for C, this is the one I wanted to throw at you. At what time will it be too late to sell the business? And that's going to be, I'll show you on a graph in a second, just like a little sketch. But that's going to be, can you just make a note for C? You're going to find the x-intercepts. I'll show you why in a second. So you want to find the x-intercepts. So the reason being is once you go past the x-intercept, then you're losing money. So that's the bad thing. So you don't want to lose money for sure. And in how many years will he break even? Well, he would be. I'll show you on the graph. It's a little bit make more sense. Actually. So think about Mr. Unlucky here. I could just. Okay. I'll just do a crappy graph. I was going to show you a nice graph, but you know. I'm just looking at the y-intercept is -4. So he actually starts down here, okay? And then he goes up, he starts making money as time goes on. I actually don't need negative time, right? He starts making money, he makes money, he maximizes somewhere, I don't know where. And then he's going to come back down, and unfortunately he's going to start losing money, okay? So this is where he started. Because he started in the negative, it takes some money to, build up the business. So this is when, what do they call it? This is when he'll start losing money. So that's why we said we're going to find the x-intercept. And to find an x-intercept, you either do quadratic formula. I'd probably do quadratic formula, just set it equal to 0. Because once you're making a profit of 0, then you start to go into the under 0, and that's a bad deal. And then you're probably saying, well, break even, isn't that like when you start here? No, he started here, so he would break even right here. So he would break even, oops, I can't write. When y was equal to -4. So you basically do the same thing. So once again, for C, I would take my equation and set it equal to 0. And find the intercepts for F. And then for D, I would take my equation and except to break even, you would set it equal to -4. Because that's where he started, and if he breaks even, that's where he'll end up. So those ones, I always think like, that's the same thing. It's really not the same thing to break even. It's where you start. So that's that. So just as a heads up on that one, and then that's it for the word problems. So what I'm gonna do is give you a few minutes. We still have like 13 minutes. Okay.